This video will revisit a couple of triangle concepts from middle school, the first of which is triangle inequalities, and the second of which is Pythagorean theorem. Let's start by looking at triangle inequalities. You may or may not recall that in order to form a triangle, the sum of any two sides added together has to be greater than the length of the third side. Notice that this says strictly greater than, not greater than or equal to. So when we go to look at the first example where they want to know which set of numbers could represent the lengths of sides of a triangle, what we're going to do is we're going to examine the smaller two sides and see if the smaller two sides added together is greater than the third side. So in looking at choice 1, the smaller two sides are 11 and 8. And if I add 11 and 8 together, I want to know, is that greater than the length of the third side, which is 19? And the answer to that is no. So those three lengths could not possibly form a triangle. In looking at the second choice, the two smaller sides are 5 and 5. And again, I want to know if 5 and 5 is greater than the length of the third side, 11. And again, the answer to that is no, meaning that those three sides could not possibly form a triangle. In the third example, we're going to take the same approach. Smaller two sides here are 4 and 3. And what we really want to know is 4 plus 3 greater than the length of the third side, 8? And again, the answer to that is no, meaning that the third choice will not form a triangle. And then the last example, the two smaller sides are 19 and 16. So again, we want to know, is the sum of 19 and 16 greater than 20? And the answer to that is yes. So those three sides, or those three lengths, could possibly be the sides of a triangle. So that's kind of the first big idea for today, that theorem. The next big idea says that in any triangle, the longer side will always lie opposite or across from the larger angle. And the opposite of that is true as well. The larger angle will always lie opposite or across from the longest side. I will tell you or caution you that you really need to pay careful, close attention. Before you use this idea to make any judgments, you have to make sure you know all three side lengths or all three angle measures before you draw any conclusions. All right, let's take a look at a couple examples dealing with this idea. In example 2, it says identify the largest and the smallest angles of that triangle. Well, in order to do this, I'm going to start by looking at the sides. The three sides are 5, 9, and 13. I know that the largest angle will lie opposite the longest side. So the longest of those three sides is 13, which means the largest angle is going to be the angle across from that side whose length is 13, making the largest angle angle B. And then they also want us to know, or want us to determine, the smallest angle. Well, the smallest angle is going to lie opposite the smallest side. So the smallest side in this triangle has length 5, and the smallest angle will lie opposite or across from that side. And the angle that's opposite or across from the side whose length is 5 is angle C. So smallest angle is angle C. In example 3, they want us to do something similar, except in this particular example, they've given us the angle measures as opposed to the side lengths. So one of the angles in the triangle has a measure 52 degrees. The second angle has a measure 54 degrees. And before we can draw any conclusions, we need to go ahead and find the measure of that third angle in the triangle. So I'm going to go ahead and use my calculator to add the 52 and the 54. Once I do the 52 and the 54, I'm going to go ahead and subtract from 180, and that tells me that the measure of angle Z is 74 degrees. So again, they want us to find the longest and the shortest, but this time sides. Well, I know that the longest side will lie opposite or across from the largest angle. The angle with the largest degree measure here is angle Z. And therefore, the side that lies opposite or across from angle Z, in other words, side XY, is going to be the longest. And then to find the shortest side, I'm going to look at the smallest angle. The smallest angle in this triangle is angle X, measuring 52 degrees. And the smallest side, or shortest side, will lie opposite that angle. So the side that lies opposite angle X is side YZ. So there's a little bit of revisiting triangle inequalities. The next idea that we're going to approach or revisit is the Pythagorean Theorem. Pythagorean Theorem, remember, is only for right triangles. That's an important idea that you should have brought with you from middle school. So right triangles only. And just to make sure that we're all on the same page and speaking the same language, we're going to go visit or revisit a little bit about right triangle anatomy. It says in right triangle X, Y, Z, label the two legs and the hypotenuse. I'm going to go ahead and start with the hypotenuse. The hypotenuse, remember, in a right triangle, always lies opposite or across from the right angle. So in my picture here, angle Z is the right angle. The hypotenuse will lie opposite or across, making side XY the hypotenuse. The legs of a right triangle are always the two that come together to form the right angle. So side XZ and side ZY together form the right angle in this triangle, and they are therefore the two legs. Remember that the Pythagorean theorem says that the sum of the squares of the two legs is equal to the square of the hypotenuse. So in other words, the way I like to think about it is a squared plus b squared equals c squared. All right, in the example up at the top of the next page, it says that we're given the diagram of that triangle where the measure of angle BDA is equal to 90 degrees. So there's our right angle in that picture. It says that the length of side AD is 5 square roots of 2. So AD I'm going to label with 5 square roots of 2. And side AB I'm going to label with 2 square roots of 15. And although they don't tell or specify in the directions, they want us to find the length of BD, the missing side. I'm going to call that X. Because we know 2 out of the 3 sides in this right triangle, in order to find the length of the third side, we're going to employ the Pythagorean theorem. So a squared plus b squared equals c squared, where sides A and B represent the legs of our right triangle, and side C represents the hypotenuse. So in this particular case, our legs are X and the 5 root 2. Our hypotenuse, the piece across from angle D, is 2 square roots of 15. So when I go to plug into the Pythagorean theorem, I'm going to substitute in X in place of the A. I'm going to substitute in 5 root 2 in place of the B. And here's where I'm going to be very careful and make sure that I use parentheses to indicate that I'm squaring not only that square root of 2, but I'm also square rooting the 5. And likewise for the hypotenuse, when I substitute that into the formula, I want to make sure that I use the parentheses. And the parentheses are really important. X is what I'm trying to find, so it's simply going to come down to the next line. To compute the value of 5 root 2, I'm going to drag out my calculator. You should drag out your calculator at this point too, and as I enter the numbers on my calculator, you should enter on yours. I'm going to add a calculator, and I'm going to make sure that as I plug this into my calculator, I remember to include the parentheses. The parentheses do indeed make a difference. So I want to do 5 root 2, and I want to do that length of that entire leg, so the whole 5 root 2 to the second power. I got to go back. There we go. My calculator tells me that's 50. I also want to do 2 square roots of 15 raised to the second power. So there's my 2 square roots of 15. And again, I want to square that entire phrase so the squared goes outside the parentheses, and that's equal to 60. So this now is 50. The 2 square roots of 15 squared we said was equivalent to 60. So I'm going to go ahead and subtract 50 from both sides. X squared is equal to 10, which means x, the length of our other leg, is either the positive square root of 10 or the negative square root of 10. But because we can't have negative length, the length of BD has to be equal to the square root of 10. Now, one interesting fact that you may not have known about the Pythagorean theorem is that we can also use it to classify a triangle. We can figure out, or we know, that if the sum of the 2 legs squared added together is equal to the hypotenuse squared, we know the triangle's right. But if we have one of these other 2 situations happen, if the sum of those squares of the 2 legs is greater than the square of the hypotenuse, we know the triangle's acute. And if the sum of the 2 legs squared is less than the square of the hypotenuse, we know the triangle is obtuse. So in example 5, they're asking us to determine whether the triangle is acute, right, or obtuse, if it even makes a triangle altogether. So the first thing we need to determine is if this triangle is possible. Well, in order for this triangle to be possible, the 2 smaller sides added together have to exceed the third side. So the sum of 5 and 10 is greater than 14. So the answer to that is an emphatic yes. And now, in order to determine whether or not the triangle is acute, right, or obtuse, I have to remember that in a right triangle, the hypotenuse is always the longest side. So I want to use this guy for my C. My 2 legs are going to be the 5 and the 10. So I want to go ahead and compare the sum of a squared plus b squared. Well, that's 5 squared plus 10 squared. And again, I'm going to drag my calculator out and enter that 5 squared plus the 10 squared. You might be able to do that a little bit of mental math. So a squared plus b squared is 125. C squared is what I want to compare that to, or 14 squared. You may or may not know that 14 squared is 196, but if you don't, just go type it into your calculator. And it just confirms that this is 196. So in this case, the square of our longest side is greater than the squares of the 2 smaller sides added together. So that's this scenario right here, telling us that this triangle is obtuse. Even though a lot of what you've seen in this video is review for middle school, there are a lot of good ideas to summarize down at the bottom of the page. So again, as always, let's take a minute to revisit the important takeaways from this video, and then see if you can apply what you've learned to answer questions 2 and 3.